One quick question. Is this clearer for you to read, or is this? This one? Okay, we'll stick with this one. Thank you. So thanks everyone for coming out today. The first thing I want to ask is, how many of you have worked with JavaScript before? Oh, okay, so everyone. Okay, so everyone is probably going to understand and feel some of the pain that I'm going to talk about in this talk. For those of you who haven't, you're very, very lucky. Should be happy. So I want to tell you about one of my formative experiences as a software developer. At my first job, the first thing that they made me do was to do customer support. And customer support in this case was deal with all of the customer support tickets that the support engineers couldn't figure out. So these were the most gnarly and hard to figure out bugs. And one of them happened to be in one of our web apps, in our single page app. And the steps to reproduce were click on something and click on something else, and then go back to the thing that you first clicked on, and then expect something to happen. But in this case, nothing happened. So what do you do as a JavaScript developer or as a front-end developer? You open the console, and then you look for whatever happens to be the error message. Now, as you know, in JavaScript, you see something like this in the console, and you're just like, what am I going to do, right? So this is what happened, and this actually, I still remember this really clearly, and the reason I'm telling you this today is because this left a really deep impression on me. This was probably the only bug that I didn't actually get to fix by the end of my support rotation. Now you might think, okay, well, this is JavaScript, right? This is fine. Like, it's fine. Everyone uses it. We have to deal with this. But I would like to ask you, is it actually fine? No, exactly. If we go to the 2018 Stack Overflow developer survey, this is the question, the question that this answers is, what is the most common technology or language that you're using in your job? And surprisingly, or maybe not surprisingly, let me move my cursor out of the way. You see JavaScript is at the top of the list, for better or for worse. So I think there are about 100,000 respondents to this survey. So there's, assuming that everyone's telling the truth and all of that, there's the minimum number of JavaScript developers is still quite a large number of people. And so all these people are wasting their time banging their heads against these kinds of error messages that are not very helpful, instead of actually trying to work on stuff to deliver value to other people. Now, because of the fact that JavaScript has all of these issues, there's been a number of improvements over the years. We saw ES6 or ES 2015, which was an upgrade essentially to the language. And so you end up with, instead of having something like this, you can actually have this arrow thing and also just define things as constants instead of just having everything as a variable. So that's a start. But there are also other things that have been developed as well. Like there's been Flow and TypeScript. Those are two major attempts to add some kind of typing to JavaScript. There's also Elm. I don't know if many of you have heard of Elm or used Elm, but Elm is essentially a completely different language that compiles to JavaScript. And there are many, many, many more of these, and I'm not going to go into detail to talk about those today because we're here to talk about Reason. But my main point here is that JavaScript is widely used, it's very painful to use, and a lot of people have come up with different ways of dealing with the pain. And today I want to talk about ReasonML being one of them, and why you should consider ReasonML in your next project, or even in your current project. So the first question that you may have, if you don't know what ReasonML is already, is what is it? And I don't want to underwhelm you with some crazy answer, but it's actually just OCaml. Who's heard of OCaml? Okay, so quite a few of you as well. I guess we're at a functional programming conference. When I gave this talk earlier this year at a more general development conference, not many people raised their hand. Let's put it that way. So ReasonML is actually just a syntactical extension to OCaml. That's it. So why do I want to talk about it then? The way that it actually works is it takes advantage of the OCaml compiler, which has a front end and a back end. And the front end is the part that actually allows us to add the syntax extensions to OCaml. And then later on, as we'll see, we'll take advantage of the back end portion of it in order to work with JavaScript. So at the moment, Reason itself is actually completely unrelated to JavaScript. Now, I want to go through what reason is, but also talk about why. So this is kind of how I'm going to structure the rest of the talk. Firstly, I want to talk about the how to use ReasonML coming from a JavaScript developer's perspective. Then I want to talk about how it actually works with existing code, because there's no point just being able to write small projects and not actually being able to use it in your existing projects. And then well, this is a little bit of lag here. Then I'm not going to talk too much about the compilation to JS, because there's not a lot of stuff there, and I haven't actually personally benchmarked it myself, but I heard that it's quite fast, so that's another thing that is worth mentioning. So, what is ReasonML in more detail? Let's take a quick look. I'm going to break this down into 4 sections. So we're going to look at these 4, and there is still a little bit of lag with this clicker. Just check. Okay, there we go. So these are the four sections that I want to talk about in terms of what we're going to look at for ReasonML. So basics. So there is a concept already built into the language, of course, of mutability and immutability. You have the let binding, and you can obviously update the value that's in that let binding, but you have to declare the let binding again. If you actually want to declare something in the more traditional sense of a variable, you actually have to use what's called a ref. And here there is a special syntax, so you have to use a special syntax when you declare it and also when you update it. And so this is a camel making sure that, yes, you actually really want to update this thing that's in here. So this is just obviously just a toy example, but I actually wrote the slides. I wrote a web app to show these slides, and this is a sample of the code that I'm using. So I'm actually I have a key down handler that actually responds to keyboard events, and I'm using a ref to store that because I don't actually want to be creating a new keyboard handler every single time. I want the same handler to actually handle the events that I'm actually sending through right now. Now, types is another big thing. So types is maybe the biggest thing, actually, especially coming from a JavaScript perspective. So why are types so special in Reason? The first is that all of your code is going to be covered with types. So this doesn't mean like, oh, I'm only going to be typing this one file that I've added annotations to. By default, everything in your Reason project is going to be typed. The other good thing, and there is still some lag, is that the types that are actually in the types that you think that you have are actually what they are. So this is what soundness of types means. And the next thing, and probably the coolest thing, is that pretty much all of the types are going to be inferred. So this is not going to be something like, oh, I have to annotate every single thing to tell the compiler exactly what the type is going to be. Pretty much, it's going to be able to have all of the basic types and then build off of those and actually infer most of the types for you. So you don't even need to like realize that you have to declare them. This is really, really cool. So how does it actually work? Or what does it look like? The first thing you'll notice is that you can just declare it by saying type. And in this case, because I haven't showed you anything more complicated, I'm just aliasing a type. So this is not super interesting. But what I can do, if I actually feel like annotating, is I can say, oh, I have a first name, let binding, and then that is of the name type. So this is how I can try and be helpful to my compiler, even though most of the time my compiler doesn't actually need it. Now, as we go through data structures, we'll see more interesting use cases of the type keyword. So the most basic structure is a list. This is similar to a JavaScript array, except that everything is the same type. So you can't have, as you can in JavaScript, because you can do anything, you can't have stuff of mixed types. Everything has to be of one type. But this means that you can have an unlimited number. Now, unlike lists, there are also tuples. So the restriction with tuples is that they have to be a fixed length. But with that restriction, you're allowed the flexibility of mixing the types in the tuple. This is a very simple way of storing something like a record. But there are also records, and these allow you to specify keys or labels for each of those things in your record. And so this is what an example would look like. And here, note that all the record structures I define are going to be actual types in themselves. So here I have a conference type, and a conference can have a name, a year, and a location. So this is the actual definition for my record. In the previous case for a tuple, I didn't actually need to declare any of these types. But here I have to actually explicitly say, this is a conference. And then I can say, let this conference be a particular instance of it. And now, note that I haven't actually annotated this conference with the conference type, because now Reason can actually infer this automatically. Now, this is what I showed you earlier as the ref that was handling the key down events. If we expand this, this is actually a type of the application state. I'm not going to show you the whole thing because it's a little bit longer than that, but I've declared the state as a record. And then there are some variables here that control the functioning of the app. So there is the current slide, which is what you're going to be viewing, or which is what you are viewing, and also whether or not we're in dark mode. So this is what I was doing before. And of course, we have the key down handler as well. Now, there are also, so we've got like the basic stuff, we've got lists, we've got tuples, we've got records. Now there are also more complicated objects, or more complicated data structures, which are called objects. And there are two types of objects. There are closed objects. And closed objects look very similar to records, actually. So you have like the key definitions here, but the way that you distinguish between a record and an open object is by the presence of that dot there. And how is an object actually different from a record then, you might wonder, apart from the dot declaration? Well, an object is actually, like, it'll actually behave like what you think of as an object. So you can have internal private variables, such as an age, but as long as you actually expose that name field which you declared earlier, then this satisfies this as being an object. And also you can declare things that actually have functionality rather than here, which is I'm just declaring some variables. And so you can access it from the outside by using this syntax. Now, if there are closed objects, there should also be open objects. What is an open object? Very similar, I would say, but because it is open, it can be it has to take another type as well. So the difference in the declaration is obviously it has to take another type, and then there's also the two dots as well, which is separated from the closed object by the one dot. So what does an example actually look like? So you have, so you can declare another a variable of this open object type, and obviously the parameterized bit is going to be an actual closed object, and the closed object can have any number of fields as long as it has those fields that are required by the open object, in this case, which is named. So we have to have a name, but we can also just have a write, because, you know, an author can write, but a person or a named thing doesn't necessarily have to be able to write. And so similarly, I have a name, like before. I can have a variable that's internal to my object, and in this case, note that I made it a ref. And for the write, I can define a function that adds something to the string. This is very, very, very basic because I don't want to show a wall of text, but this illustrates the fact that objects are essentially another layer of expression over what you can do with, say, records. And so this is how you would actually use that. Now, I've just talked about all of these data structures. So we have list, tuple, record, objects, and these are all part of the Reason language. And you might be thinking, okay, well, why? So actually, one of the things that people have asked me is, why would you use all of these things, and when would you use all of these things when you could just use arrays and objects in JavaScript? And I'm just like, no, because the very fact that you're forced to think about the exact thing that you're expressing will mean that the program can actually help you and guarantee correctness, instead of just say, I'm going to use an array for and put whatever I want in the array, or as often is the case, objects can be used for, say, maps, but also function objects, but also modules as well. So I think even though it seems like there's a lot of stuff, especially coming from a JavaScript perspective, I think it's very helpful to actually know exactly what you need to use for your use case. And it's good that the compiler forces you to kind of think about that. Now, I'm just data structures are great, and so far this is pretty cool, but I haven't even gotten to the coolest part, which is pattern matching. And of course, as functional programming developers, this is bread and butter. But from a JavaScript perspective, this is holy moly, this is so cool. Why isn't this everywhere, you know? So there is another type that you can declare in Reason, and that's called a variant. And the variant, basically, I can specify any number of things. So this is like saying this something can be this thing or this thing or this thing, and so on. So in this case, I have a very basic one. I have the login status, and I can either choose to have like the bare variant, or I can also have a variant that has another value inside it. So in this case, I have logged in, and maybe the string indicates the user. In the case of this slides application that I've made with Reason, I have an action which indicates when the state of the program should update. And these are the actions that I've got, or like a subset of the actions that I have. So I can go backwards, I can go forwards, and I can also jump to a slide because it's a web app and I have like a link where you can, if you go directly to a slide number, it will load the page with that slide number. And obviously toggling dark mode, as you've already seen. So why is having a variant really useful? So you can pattern match against it, and that this is really, really cool. So I can have a status that is a particular case of some variant, and then I can switch on the value of that. And I think you all know what this is going to look like. So I have to pattern match on all of the possible cases. So the really good thing about this, especially coming from a web dev perspective, is that because you have already defined all of the options of your variant, the compiler is going to force you to handle all of the cases. And the good thing, so that's one good thing. The other good thing is that if you forget to handle one of them, the compiler will tell you. It will be like, hey, I think you're missing this one, and so you're actually forced to add it, and this is like someone is like pair programming with you essentially, and they know everything. So it's really good. But obviously, like in this case, the minimum cases I need was to handle not logged in and also the generic logged in user, but I can also pattern match against specific cases as well if I'm interested in doing something in response to those. Now, of course, you can pattern match against variants, and this seems pretty obvious, but you can also pattern match against lists, and I'm sure this is also very obvious to most, if not all of you. So you can obviously do something like this. I can do something with the head, the list is empty, and then I can do the standard thing where I want to do something with the head. So this, you can also, of course, do this, but this is also like another one of those mind-blowing cool things. And this is also what I'm doing here as well in order to parse the numbers for which slide to actually jump to in this slide app. So I'm parsing the segments of the path. And I only want this, so I'm only interested in two cases. If it's in this particular structure, so it has the hash, so this means I'm not like directing to another page, I'm staying on the same page. And then I have two numbers. So one of the numbers is like the slide itself, and then the other one is B is going to be the index of the content in that slide. Because as you could see, I was showing stuff progressively on one slide. So this is the exact structure I'm interested in. So if I am able to get something of this structure in the path segment's value, then I will go ahead, and this is some stuff that you don't need to worry about, but this is because of what I'm using to do this, which is Reason React. So then I send an action to actually update the slide to go to the correct one. Otherwise, I just don't give a damn, really. Like, just go to 0, because whatever you gave me doesn't really make sense. We're starting at the beginning. So this is an example of using pattern matching. It's like you can see what it is doing just by looking at it. You don't need to write some kind of complicated if and and so on. Another thing you can pattern match against is, of course, anything really, but this is one case that I particularly like, which is you can actually use, instead of doing like if something and something, or like if else, and like all these complicated combinations of one or more variables, if I wanted to pattern match against the values of two variables, I can just draw them out essentially in a table like this, and this becomes very clear what's happening straight away without me having to trace through whole complicated blocks of conditionals. So I really like this as well. A special mention is the option type. And this is, of course, also fairly well known to many of you, but in Reason you have this concept of the something being there or something not being there. And this is also a special case of a variant. What this means is that you can pattern match against it because it's a variant. And in this case, I have some logic for the full screen of the application. And I am switching on whether or not this particular DOM element actually exists, which is actually the root of my application. And there are two cases to this. It can either exist or not exist. So if it does exist, and I get that element, then I can actually call request full screen on it, which is a web API method to actually trigger the full screen thing. Otherwise, I just don't do anything. So in this case, I'm forced to handle both, and I'm not going to get any of those, like cannot find request full screen of element or whatever. So this will just work. And what this means is that I'm never going to actually run into the problem that I started with at the beginning of the talk ever again. It's like, yes, good. Okay, so one more thing is extras. In JavaScript, you have a bunch of JavaScript files, and then you have to import and export the things that you actually want from them. In Reason, every file is a module by default. So you don't need to say, like, especially say, okay, this is my module file. Not again. So, yeah, so every file is a module. But the other thing is, you don't actually need to import any modules. So the compiler can actually see all of the Reason files that you have and all of the symbols and stuff that you have in them. And then you can actually directly use something from one file in another file. So you don't need to say, you don't need to explicitly say, I want to import this from this file. And what this means is that you can actually change the structure of your project very, very easily. And the reason I put this as a plus is because in my previous job, we were starting out a front-end repo from scratch, and it was a React project. And we had structured the folders in a particular way. And then as we added more components, we realized that it wasn't actually, the structure that we had didn't really make a lot of sense. So then one poor soul was tasked with the task of having to update all of the import lines in all of the files and also changing all of the directories as well. And then you can imagine, even if you have something like Git, which is what we were using, you can imagine it was a nightmare because other people were actually still making changes to it, and then whenever they would go and merge, it would be a nightmare. But with Reason, you just don't have this problem at all. Like if you don't like the structure, go ahead and change it, because the code knows nothing about the actual structure of where the code actually sits, and I think this is a good separation. Another extra thing is the fact that you can also use functions and symbols from other languages. So in this case, a very common one is by using something from C. But as we'll see later, we'll also take advantage of this in order to work with JavaScript. So all you need to do here is you need to declare the symbol that you want to use in your Reason code, and then you need to declare the type, obviously, and then the very last thing at the end is the thing that you're referring to in the foreign language. So now we've looked at ReasonML really quickly in a nutshell. I pretty much told you all of the major things that you need to know. Now, we can see from this that they've tried to make the syntax as accessible to JavaScript developers as possible. So if you've done OCaml before, you'll know that many of those things look a little bit different to what I showed you. And the goal of the team who developed this was to essentially lower the barrier to entry for these people. But then it's no use to actually do all of this work if there is actually no way for you to use Reason in your existing projects, which I think is a really important case. And also, it's not very useful if you are only living in your Reason bubble and you can't use stuff that already exists in JavaScript. So the interrupt story is what I'm going to talk about now, and I think it's a very important one. How does it look? We'll cover this in 4 steps, similarly to the previous section. And I'm getting some delay again. Yeah, so I want to talk about the relationship between Reason and JavaScript, which I think will then kind of make things full circle. Because right now I've just been talking about Reason and I haven't said really that much about how it's actually going to work with JavaScript. Then I want to talk about the 2 directions. So firstly, I want to talk about how you can actually use JavaScript things in your Reason code, and then the other way around. Because a lot of the times, especially especially now, you're going to have to reach in and use stuff and vice versa. And then finally, a call to action. So remember at the beginning, I showed this OCaml compiler, and I said that there's a front end and then there's a back end. And the front end is what allows us to do the syntax extensions. And then the back end is what actually allows us to take the, essentially the generated, okay, rewind back a little bit. So when you have your OCaml code, and then there are several steps that it goes through in order to determine the output of the code and when it actually gets run. Now, the front end is the part that allows you to extend the syntax so that the compiler can understand more symbols. Right, and then it takes those symbols and then generates an intermediate representation. Firstly, the representation is untyped. Then there are some type inferences that happen in order to actually make sure the whole thing is typed. So you end up with a typed AST representation. And then at that point, this can be transformed either into bytecode or native code, or we can also add another backend that will then transform it into JavaScript code. So that's kind of how this works at a high level. Now, the thing that actually does this transformation is called Buccal Script. And Buccal Script allows us to take one reason file and then generate a JavaScript file from that. What you can then do as a result is you can then use this generated JavaScript file like you would if it was actually a file that you wrote in JavaScript. And the cool thing about this is that the files that are actually generated is not like some garbage that you can't really understand. They try really hard to make it so that you can understand what's happening in the JavaScript and also map it back to the part of the reason code that actually generated that JavaScript. What do you need to do this? You think it might be complicated, but you actually only need two things. So firstly, you need a configuration file. And the other thing that you need is to install a little tool called BSB. So what is the minimum configuration file? It's not complicated at all. This is the minimum configuration file that you need. You have a name, and then you need to you need to be able to specify where your reason files actually live. In this case, it's source. And BSB is a tool that you can simply install. Once you've installed it, you can run BSB make world, optionally with the -w flag, and it will watch for all of the changes in your reason files and then compile them. And that's all you actually need to get started. So this is the minimum structure of your project at the beginning. Now, so what this means is that with those small steps, you can actually start writing Reason apps from scratch. And they will get converted into JavaScript, and then you can actually use them. So that's all there is to it. But the more interesting thing is, how do those two languages actually interop? So I showed you this way of declaring bindings from external languages. So when you use Buccal Script, there are often more complicated cases when you're trying to use stuff from JavaScript in Reason. And there are various things called Buccal Script directives, which you see in the square brackets here. There are various things called Buccal Script directives that kind of tell Buccal Script how to get at that particular piece of JavaScript code. So let me illustrate what I mean. In the very first case here, you see external and then see string compare, right? And here we're kind of assuming that there is this, in kind of like the global namespace, we're assuming that there is something called strcmp that we can use straight away. So here it was a very straightforward case. In the case of, in JavaScript, sometimes you have things that are in the global, so you can use them directly, and that's very straightforward. That's what I'm doing here. But sometimes you want to use some attribute or some function that is only present after you've required a module, for example. Sometimes you can only use something after you instantiate an object from a module that you require, and then so on and so forth. So the bs.directives allow you to express that kind of logic. So in this case, I'm doing something very, very simple, which is I expect something called b to a function that takes a string and gives a string. And then I'm going to import it and use the binding b to a as well in my reason code. And what this means is that in my reason code here, in the third line, I can call b to a directly with the string. And this will type check as you'd expect. The danger of this, of course, is that when you declare the binding in the first place, the danger is that you can declare the wrong binding. And so you may end up with runtime errors. So bs.val was one of the directives. There are also many others. For example, bs.module here is what allows you to import or require another module. And this you'll use fairly often if your code wants to use other JavaScript libraries. bs.scope is another one. bs.new is when you have to do a new. bs.unwrap is when you have to deal with functions that take an argument that can be several types. Because it's JavaScript and anyone can do anything. And there are more of these. I haven't counted, but there are quite a few more. And to kind of show you some more examples of how this actually works so in here I am using another library called highlight.js to actually do the syntax highlighting of my code. In order to actually use one of the functions that it has, which is highlight block, I have to actually require the module first. So in my plain JavaScript, I would write something like module var or const highlight.js equals require highlight.js. And then I'll have to do the module.highlight block. In this case, I use bs.module to express the fact that I want to actually require it. And then once it's required that, I know that there is a function there called highlight block that I want to use. And so I'm importing it as the same name, so that's why you see highlight block there. And then I declare the signature. So this is going to take a DOM element and then give back a nothing because I'm just highlighting. It's a side effect. So that's one use case that I'm actually using in this app. And another one is what I'm using to actually convert the content of the slides. So the content I've written as Markdown, but then I want to actually render the Markdown as HTML. So there is a library called Showdown, and the way that it expects you to use it is to instantiate a new Showdown converter and then call things on it. So in this case, I need to actually keep an instance of this converter. And so what I'm doing here is I have to use BS module first in order to require the Showdown module. Then I have to use new to say that, yes, I want to actually create a new instance of this converter. And then I'm keeping this Showdown converter somewhere else and then using it to actually do the rendering later on. And also you'll note here that I've declared, you see the Showdown converter and then the colon and then the small case converter. So here, the lowercase converter is actually a type that I've had to declare beforehand in order to tell Reason what this converter type actually looks like. So these are some examples of how you can actually use existing JavaScript libraries in your Reason code. But the thing with this is it actually took me quite a few iterations of trial and error to actually get this exactly right. And so before you do this, you'd actually want to check for existing bindings. Luckily, people have already started writing a lot of bindings. I took this screenshot in April, and so I'm sure there's been more that's been added to it in the meantime. But first, if you ever want to use if you're working in Reason and you want to actually use another library, first check the Reason package index or redex, because they've actually done all the hard work of figuring out all of the things for you, and it's very nice. But if they haven't, you can write your own bindings and then add them to redex. So that's also nice. Now, if you're lucky and you find a binding, how do you actually use it? So before, we weren't using any bindings, so all the stuff that we wrote was part of our code. But once you find a binding and you want to use it, you need to add it to another section in that config file that I showed earlier. So that section is called BS Dependencies. And in this case, or in this project, I'm actually using the bindings that already exist or these are the bindings to the web and DOM APIs, which are notoriously difficult because of the way that they are. So luckily someone has already written bindings for it, even though they're experimental, I'm still able to use them. And that's actually all you need to do. So this is how you use the existing bindings, and then because you have those names, you can then use those names directly in your reason. So you may or may not remember, but as I was showing some code, you were seeing stuff like dom dot something, and element dot something, and those names actually come from the BS Web API bindings. So that's using JavaScript in Reason. To summarize, you either have to write your own bindings or find bindings that other people have written. And it can be error prone because you have to figure out how the types map exactly. But it's worth it once you get it. The other direction is how then do you use your Reason code in your JavaScript project or code. And so this is kind of the story of how do you write stuff in Reason and then actually slot it into your existing projects. So again, we go back to the bsconfig.json. And we've seen all of this. I've just changed the formatting so I can fit more stuff underneath. First thing you need to do is you need to declare the type of the modules that you're going to generate. So remember how we're saying that Reason, we can write Reason as it is, and then Buccal Script will turn the Reason into a JavaScript file. Now, it has to be able to figure out the module format that your project or that you actually want. So you need to specify it first, and it supports a few different ones. And then here is just saying, do you generate those JavaScript files alongside your Reason files? Another thing is you may want to distinguish your generated files from your actual files that you've written, so then you can optionally add a suffix to it. So in this case, anything that ends in .bs.js obviously is going to be generated. Otherwise, if I just say JS, then I would have to open the file to look to actually figure out whether or not it was generated. So once you've done that, and so just a quick side note on the module types, you have CommonJS, and then you also have the ES6 as well. I think they had AMD, but they removed it at one point. But I have to double check the manual again for that. So that's actually it. So what we've covered here is we've seen that you can have your Reason, and then you can use Buccal Script to turn the Reason into JavaScript. And then we saw that you needed to write some bindings in order to actually use various JavaScript libraries in your Reason code. And then the other way around, you can directly use your JavaScript generator from Reason inside your existing JavaScript projects. And that's actually all you need. So how do you get started, or how do you take advantage of this? So the first thing you can do is just by starting to write a new Reason file. This is very easy to actually start doing this. What you can then do is you can start to convert existing modules in your file, in your project, so existing JavaScript files. You can slowly start converting them into Reason, and because you have the interrupt story, you can actually start using them directly. And over time, maybe you'll actually profit from the conversion. So to summarize, why Reason? Number one, I believe it is fairly accessible to JavaScript developers. Number two, the interrupt story is something that they've put a lot of effort into in order to actually make it work with existing projects, and also because you actually want to use the vast ecosystem that JavaScript actually provides. And also, I've heard from secondhand sources that the compilation is very, very fast, especially as your project grows over time. So to recap all of this, we saw JavaScript can be painful. I don't think anyone doubts that. But people are doing a lot of work to try and make it less painful. One of those candidates is Reason. We know that Reason is a syntax extension based off of OCaml. So that means that not only does it add extra syntax to OCaml, but it also allows the developer to take advantage of everything that's already in OCaml. And because OCaml has a lot of history, this is like you can use a lot of stuff that is already there, which is really cool. Then we saw various features of the Reason language, and we were wondering why would someone actually want to use all of these things, especially if you're just used to using arrays and objects. But we saw that this allows us to express the things that we actually want to express in more precise ways, with the added benefit of the compiler helping us. And finally, the interrupt story is something that is fairly well developed, and the point is that they want to actually make you use it and go ahead and adopt it in your existing projects. So this is the end of my talk, but I'd like to think that this is the beginning of a new way for people who are working with JavaScript applications to spend less time working on things that are really just like artifacts of the language being difficult, and spend more time working on stuff that actually matters. Thank you for attending my talk.